Should we do Zoom?
Yeah, if it's going to bother you, then yeah, probably, because otherwise it'll be just more difficult. Do you know how to set it up? Because I haven't tried yet.
I haven't tried it either, actually.
Alright, let me try it. I downloaded the app this morning, and I think you can create stuff through there.
Yeah, and otherwise we'll just do it here, and it'll work somehow.
A new meeting. I'm going to hang up on you now, okay? And then you can talk through Slack.
Alright. Can you hear me?
Yeah, all good.
I think it's better.
Yeah?
I think so.
Nice.
Alright.
That does seem better, actually.
Yeah.
Cool.
Good. So thanks for taking the time during these difficult times to talk. So basically, just to give some context, I'm writing my master's thesis on the topic of how product development and deployment in the context of AI differs from more traditional contexts, and what companies can learn from cases like Merantix to kind of take a structured approach and a more certain approach on how to successfully do that. And so I'm doing a case study with Merantix, and I'm interviewing both the business team and the machine learning or the entire tech team, actually, to get all of the perspectives. And I'm focusing on the timeline since actually even before the foundation of Merantix Healthcare. So when Adrian and Rasmus were, brainstorming which area entirely to go into, up until the point where we are now. I'm trying to identify kind of key phases, and within that, what did people do? How did the teams interact? What challenges occurred, and how were they overcome? And so basically, the interviews that I'm doing aren't very structured. It's just about talking about your perspective, talking about what the key phases were for you from when you started to now, and we'll just find questions to dig deeper. There's no predefined questionnaire on it or everything. So what we could do is we could just start by, if that makes sense for you, start by where the point in time where you joined and what the situation was there and what your kind of initial task was, and so on.
Sure. Yeah, so I started in November 2018.
Mm-hmm.
All right. Yeah, November 2018. And at that time, so it was Stefan, Benjamin, Tobias, Christian, me, and Jacek at the time, but who left soon afterwards.
Mm-hmm.
And the initial thing I was tasked with doing was basically trying to produce some infrastructure which identified what errors the model made.
Yeah.
With the hope that would teach us something about how to improve it.
Yeah.
And I did that for a few months, I guess. And it mostly just led to us finding like mistakes in the data. It didn't lead to very much on the model side in practice. But it was it was a kind of interesting lesson in making sure you actually look at your data, which everybody says, and of course we did, but just how much you should be looking at it. Because, for example, we found like some images where they'd been pre-processed incorrectly, and they were like inverted. So the background was white and the breast was black, for example.
Okay.
Things like that. So that was the main thing that came out of it, and indeed we found like some of the annotations which were just a bit wild. Like somebody had put 50 annotations on one image, that kind of thing.
Yeah. Okay. So you were basically faced with a bit of a mess, maybe, can one say that?
That's probably not representative. Because it was like, they're mostly completely fine.
Okay.
But out of a few, yeah, we're talking about like a couple of % or something. Most of the things looked fine. But nonetheless, it was something to need to be fixed.
Yeah.
So I did that for a couple of months or so. Built some, just mostly building infrastructure. There wasn't all that much thinking to be done.
Yeah.
And then moved on to other things in the spring of 2019 or early spring 2019, something like that.
And so the when you started, it was already clear that it was going to be Mammo, because before you started, I think they were exploring different cases, and also the machine learning team was working on different models. But when you started, it was clear that it was going to be a screening setting in mammography, right?
Exactly. Yeah. Even more than I joined it was like everything. When I joined, everything was like actually, so not just that it's mammography and screening. I mean, when I first joined, it was still thought that in time we would do other things. I think that got banned sometime summer last year or something. That stopped the plan. But at the time, we were absolutely doing that, and things were fairly mature. Like they'd settled on a model which we've subsequently changed. They sort of subsequently changed that model. But when I arrived, it was very much like, here's our task, here's our model, here's what we're going to do.
So was that
really any of those decisions? Sorry?
Was that public model? Because Stefan said you first used a public data set and a public model, publicly available model, and only after a certain period of time he noticed that it's kind of not scalable and customizable enough, and then you started, or the team started building another model. I don't know if that's the same, if that's what you were referring to just now, or whether that happened maybe before.
It's hard to say, really. I mean, so there was definitely, when the first sort of like, up until last spring, we used a re-implementation of a like fairly standard object detection model called FastRCNN. And that was done, I think, because basically there was this public challenge.
That DREAMS thing.
Exactly, yeah. And that was one of the successful candidates. But it's been lots. So if you spoke to people outside of healthcare and they found out we were using FastRCNN for the task, they by and large don't think it makes sense, and I didn't think it made sense.
Okay.
I wasn't really around. It's not ridiculous. Don't get me wrong. It's not like super wrong. It's not quite. It wasn't what I would start with, and it's a bit complicated for a thing to start with. And then since spring or something, I was reallocated to working on this newer model.
Yeah.
And so that one and its subsequent sort of incarnations have now replaced that FastRCNN.
Yeah. Okay.
So just to give you context, if this comes up again, like basically FastRCNN seeks to draw boxes around things, right? So if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the cats. And then if you have a picture with 10 cats in it, it tries to put boxes around all the c breast cancer, boxes are not particularly well defined. You're not ultimately that concerned with localization. What you want is just to say, is this bad or not? And just the faster RCNN is just very, very complicated. So it leads to quite a lot of sort of technical debt.
Okay.
It's just a complicated model.
But I mean, in the maybe wasn't it more logical to use faster RCNN in the beginning when they were more on the CAD track? Because I mean, the task then changed from CAD to smart classification or smart elimination, right? And maybe didn't it make sense in the beginning?
I wasn't around then, so I have no idea. I never knew that we were thinking of doing CAD because I was only ever told because it doesn't seem to have been very useful. So I didn't know that we were trying to do that at any stage. Maybe we were before I was around.
Yeah, because apparently in the beginning, when they were exploring cases, and the first time within that exploration, when they were in Mammo, kind of the standard thing to explore was CAD, because of iCAD and other companies already doing it, but it kind of lacked a unique. It wasn't really unique because others were doing it, and it didn't really address a real pain point. So only after that they kind of switched from CAD in a diagnostic setting to real smart elimination in a screening setting. So probably that might have also been a justification for using that model, but I don't know. That's just a
that
thought.
would make a lot more sense. And also, I mean, I should say that like having a model which is interpretable is very much a good thing. And it would still be great if it was. But that's kind of a research topic in and of itself. It's quite difficult to know exactly why these things make decisions.
Yeah.
And fast RCNN would have done that nicely.
Yeah.
I think the only thing is, in hindsight, like it's always easiest to start with something simple.
So with a
simplest thing and move on from there.
Okay. So that would be faster RCNN wouldn't be, or fast RCNN wouldn't be a simple thing, or would that be a simple?
No, I don't think that's. I think most people would agree with that. Yeah, just in terms of the amount of work required to implement it. Also remember, it requires. So you have all of this data to begin with, right? Which is just labelled on an exam level. There's this. Says there's something in the left breast.
Yeah. Right?
And so in order to train a fast RCNN model, you have to go in and label. You have to go in and draw boxes on every one of your thousands of images.
Yeah.
So that's also a huge amount of complexity. I don't think that was a mistake in hindsight, but you don't necessarily know at the beginning how much you get back for that.
Yeah, that makes sense. It was kind of it could have gone wrong. They could have had 15 freelance radiologists annotating, and in the end, maybe it's not even the model that doesn't work, it's maybe even the business case that doesn't work, and everyone's been annotating and building a complex model, and then you don't really need it.
Right. Yeah, I mean, because, say for example, right now, our best model now, the final stage of it just looks at entire images with no annotation on them at all, and learns from those. So the open question is, could you just do that from the start?
Yeah.
Right, and that might save a lot of money and time. I suspect not. So it's not something that keeps me up at night. But equally, it probably makes sense to try without first.
Yeah.
That's all.
Yeah, I mean, it's kind of a complication, and kind of, if I think of it from the, if I think of possible challenges in general, and from a bit of the business perspective as well, currently we're looking at the, I don't know how involved you are in that, but we're looking in, or Dipti and Max have been looking at safety nets, the function where you would help, you would warn someone with localization. So, hey, there might be something that you have to look at, and then drawing a box around it, and even specifying whether you would draw a box around only masses or only architectural distortions and so on, or only calcifications or whatever. So if one wants to look at that now, we have the option of doing that, probably because you already were developing. I mean, this is more of a question, actually. Do you think, or how easy is it now to switch to those more detailed things? And does it, are we ready for that, or?
So the issue, there's two orthogonal issues, right? Number one is that phosphorescence is more complicated, but that's not a reason to not end up with it. The second issue is that, in my opinion, it's not suitable for the task. Okay, and that one's more important because actually our fast RCNN model is significantly worse than the thing that looks at whole images at a time. So if you wanted to do a safety net, it would be very easy to say why the faster RCNN thinks there's a safety net. But right now, our current model doesn't really localize.
Okay.
So when Stefan says that we could draw a box around it, that's actually, we could, but that's from like this intermediate model which looks at patches of the image individually.
Yeah.
We don't actually know how that relates to the ultimate decision. So certainly we could draw a box. I think Christian and I are a bit more skeptical that you really don't know what that box means.
Okay.
It's a discussion for another time. Yeah.
But in that case, would there be two models? So would there be first the model for the work list, classifying as normal and not normal, basically the simple model, and then if we want the safety net, we would use another model? I mean, you would have to do it like that, right? Because the first...
in order to draw a box?
Yeah.
Yeah, to draw a box, it wouldn't be the same model making the decision.
So you would take the first model, I mean... Basically, that's not even that relevant for my thesis, but it's just out of interest. You would take the first model to give the basic decision normal or potentially suspicious, and would you use that model to decide whether or not to deploy the second model for cases where the first model sees it might be cancer? Would the decision to activate the safety net come from the first model or from the second model kind of working in the background?
So the honest answer is nobody's talked about it.
Yeah.
So, don't know. Obviously, if you're making it, in my opinion, there's no point having interpretability from a different model than the one that made the decision.
Yeah.
Doesn't make any sense. So yeah, either you would have to use this patch level model, this image patch model, to make the decisions and then show where that decision came from.
Yeah.
Or you just have a safety net that isn't localized, or you do something more complicated, which means that there are ways of adding interpretability to models. So down the line, you could make our current model interpretable with some extensions, etc.
Okay.
None of these things. I mean, we're basically, before you go down any of that path, the important thing to do is just decide, with this safety net, potentially you might be making them refer many more cases, right?
Yeah.
And maybe you're not catching that, you're only catching the cancers they would have got anyway.
Yeah. So
you need to just check, what I'm doing right now is just checking that those two things balance out in a way that's advantageous.
Yeah. Like
a plausibility thing, where are we with respect to this being useful or not? So.
Okay. Makes sense. Okay, so if we maybe go, if we think about, and I think I already know the answer, you even wrote it a bit in Slack, but just to get that, I'm not looking for an answer to this question, but the question of your collaboration and how, or direct collaborations, or actually in meetings, and also indirect collaboration where you kind of know that there are impulses from, let's say, just the business team in general. How close do you think you are? How do you see the collaboration? And I think, yeah, with.
Honestly, barely. It's a surprise. You couldn't tell we work in the same company. I don't know what your plan is with regards to quoting me on this stuff, but
no, that's great. That's exactly what I thought you would say. And And
I'm not looking to ruffle any feathers, but honestly, if you're asking, I don't think I've ever had a meeting with anyone from the business team.
Yeah.
I think I had one one-on-one with Jonas when Stefan was sick. Other than that, so basically, I don't know if that's different for other team members, but as far as I only hear at the Tuesday updates, or indirectly through Stefan.
Okay.
But then often that there's some filtering mechanism there. So I'd say I know what the broad aims are. It's not like I have no clue. But I won't necessarily know where the decisions are coming from on the other side, if you know what I mean.
Yeah. And do you think that, intuitively from a textbook approach, one would say working in silos and not having to do with each other isn't a good thing, but what do you honestly think if you would have to judge that situation? And by the way, I'm not going to... that's not information that's going back to the team or anything. That's really in my thesis, so don't worry. What would you? How would you comment on that?
I don't know. It's really interesting. So are you looking only at healthcare?
I'm looking only at healthcare. Yeah.
I see. Yeah, because it's very different in automotive, and that's quite interesting.
It's different in automotive.
Yeah, the work culture seems to be completely different, which is kind of interesting. What do I think? I mean, I don't worry that I'm not like there listening to how the business decisions were made and stuff. I think at times something slightly more joined up would allow me to react a bit better. There have been times where there's some big deadline coming up and I'm just not aware of it, and there's things I could have done to help.
Yeah.
So in a large, I would probably shift it a bit more joined up. And I imagine if some people join startups with the attitude that they really like it because of the ownership you get over it and discussing all the decisions and that kind of stuff, which I respect. It's personally not me, so I don't worry about that. I broadly trust the people in the business team, and so I'm quite happy with it. But yeah, a bit more communication could be better, I think.
Yeah. So can you give an example of a point in time where where it would have been good to react a bit better? Do you have a specific example?
Oh, there was just one time where I found out that for regulatory reasons we had to certify our model, and it looked like it was going to be locked in for months. It couldn't be improved, and I think I found out 2 days before it happened. And the previous week, I'd been doing other things, like coding things, and I could have been improving the model, and potentially those improvements would have been locked in for 4 months or not. I mean, in the end, it didn't happen, but at the time, I was a bit oh, well, yeah. So that's what I think. It was something that was going to be. I think it might have even been for these third reads, which we're now doing off-label, but at the time, it was going to be an on thing. Yeah. And so, the data that we would have got to look at for ages would be based on this model, and then it would actually have mattered how good it was. So that was a bit of a surprise to me.
Okay, that makes a lot of sense.
Third reads and things, I don't really know what's going on. Well, not that I don't know anything, but I don't really feel like I have a sense of what's going to happen and what data we produce and stuff.
And how is it would still be interesting to hear, if you say automotive is different, how is it actually different?
Oh, they seem to just have meetings all the time, which go across the different teams, and the decisions seem to be much more communal, or just sort of voter-based and consensus-based.
So even about decisions that wouldn't even affect any part of the machine learning work, you would have they have meetings and people can vote on that, or
good question. I don't know exactly how it works. They just seem to be doing many more there just seems to be much more exchange.
Okay.
And the decisions are made, even the technical decisions are made more on consensus. I don't have a particularly strong opinion on whether that's better or not. It's just interesting that it's different.
Yeah.
Yeah.
Okay, interesting. So if we maybe look a bit more at the timeline in general, you know, we so from November 2018, obviously, what do you think are kind of the milestones or things that significant points where you achieved something or where you changed an approach or something? For example, switching to a different model or something to do with the data infrastructure that affected you, or whatever basically.
Okay, I'll give you two examples. One from the model side and one on the data side. So one is so what replaced the first RCNN was basically a patch-based model. So you take slices of the images, maybe containing cancer, maybe not, and you learn to classify those instead, right?
Okay.
So, which is an easier task, right?
Yeah.
You just get on the thing in question or you're not. Right?
Yeah.
So that model goes really well. That was the one that we started building in the spring, mostly through Stefan's initiative, I think. And then that was working pretty well. But of course, the question, the point is, you're not really interested in classifying patches, right? You're interested in classifying whole exams, which contain tens of thousands of patches. So what we had been doing is just like running over all of the patches in the exam, and you take them one most suspicious one.
Yeah.
And actually that worked pretty well. It still worked better than FastRCNN. But it led to various problems, which I can tell you more about if you like, but I'll just carry on first. But there are various indications that that's like not the best you can do. There's other reasons you could do better.
Yeah.
And so kind of looking at certain strange behaviors in terms of the training and also the predictions, Christian and I sort of predicted that what you really want is like another model which kind of sits on top of that and aggregates all of these patches into one image score. And we sort of slowly advocated for that, presented the evidence, worked on it, and then it gave us a kind of a really big jump in performance, like 5 AUC points or something. That was just
okay.
Was it November?
In November?
And that's our new model. And since then it's kept going up as well. Sorry, go on.
So that was in that performance jump was in November 19.
Is that right?
Or you said November.
Sorry, not the 19th of November, but November 2019.
Yeah. I mean, it was in November 2019. Okay.
Yeah, that's right. Yeah.
Okay, so you had basically you started with FastRCNN, then you went to that patch-based model pretty much in the beginning of your time at healthcare. Is that correct?
So Stefan, it was Stefan's idea. I did the implementation, and I was doing that from March until I don't know, September or something.
Yeah.
Then started pushing for this Nexus image level model, which has now replaced it.
Yeah. Okay. Makes sense. And so the performance. Do you actually have? Because maybe that's even something that makes more sense to have on paper. Do you have an overview or a graph or something of the model performance over time?
No, but it would be easy to construct one for you.
Really, because that would be amazing.
I think so, yeah, because I don't know I can't remember when we started doing it, but quite early on in GitHub we have like at the top of the configuration files, it says what the baseline is and what the performance is. So just by looking through the history, you can see it. I'm sure Stefan probably has he might even, yeah. So someone can definitely make that for you. That would be amazing. At some point, yeah. That would be nice to have that over time and then see kind of what you did and what changed the performance. Yeah, so there's a combination of two things. It's like discrete changes like the one I just described, and then also just a very which gets less credit because it's sort of slow and cumulative. It's just the improvement on the data side. I think Stefan had Dominic go back and use all of the old labels from year and a half ago with a new model, and it's much, much worse.
Okay.
But you never see that all in one go. So the labels are slowly getting better as well, and that's harder to see.
But isn't there also a third one? So you said there are discrete changes of the model, so changing the model. And then there are the continuous improvement of the data, so of the quality of the data. But isn't there also a third one, basically continuous improvements of the model? Because you can change the model type, but then also work on refining the model, or is that not true?
Certainly true in principle. Given the size of the data set we have to evaluate, it's quite hard to know.
Okay.
The measures of, you might get different opinions on this, but the measure of performance of the model is fairly noisy, just because the data set size is not huge.
Mm-hmm.
And you can imagine that intuitively, right? You evaluate on 100 cancers, and this new model happens to get this guy but not get that guy, and that changes the shape. Actually, in the aggregate, maybe nothing changed, or maybe it got slightly better, but you can't tell, etc., etc. Okay. So certainly that process is happening, but it's very difficult to know because all those three things are mixed together. So what tends to happen is you only really notice is when there's a big discrete change.
Mm-hmm, mm-hmm. So basically, because of the data volume and the changes in the data and its quality, it's difficult to see what continuous changes to the model would have, what the impact would be of adapting the model.
For us, because our data set is scarce, and our data is scarce, obviously we have tons of mammograms, but the cancers are fairly scarce. Yeah. If you had a huge data set, like Google or something, then really you could be like, has this moved the needle a tiny bit? Mm-hmm. You focus on Google or something. Us, it's more difficult. And by the way, when I say discrete changes, I don't mean only just producing a new model. I might also just mean somebody adds data augmentation or something, and you just see it tick up by 1 point or something.
Okay.
So, machine learning models, often 1 point in AUC is considered a significant improvement, but the noise level is about that. So that means that it's hard to notice anything other than a significant change. Mm-hmm. But yeah, that process is probably happening in the background.
Okay. And so, maybe, some things obviously come from decision. Basically, your task is to have a model that that has the best performance on the task that we need, right? But are there also decisions or things that you see within your team that require the, for example, business team to collect new data or something? So some decisions, so the specification of what the task is probably came from Jonas in the very beginning and from others on the team to see what do we actually want to solve, what problem do we want to solve. But there must also be things that you kind of push to the business team or to the data, to Florian, for example, when he was still doing the annotations. Are there things that you initiate that influence the other team?
Well, in the beginning, there was this process for us finding funny-looking images, and we're looking for re-annotations. Mm-hmm. I'm not sure. And for example, we found this study with 50 annotations in it, and it was redone.
Yeah.
Not sure. So you were saying specifically about business, or just with people outside?
Yeah, maybe we can just say people outside the machine learning team, because what I'm getting at is I want to try to see how are the interactions, who triggers what, and it can be in the software team. I'm assuming there's more in that team, but it might also be with the business team, Yeah.
So with Benjamin and Dominic, they do loads. I've talked to them loads. I need this. Is this feasible? How should I do it? Etc. So the other example I was going to give you of something that changes is on the data side. It's a little bit more along those lines.
Yeah.
So it's kind of funny actually, because it's something which is quite, in some ways, quite obvious, but we didn't notice until the kind of the right environment comes up to notice it. So I was looking at, so for our most the latest, greatest model, this image model, what errors does it make? Can we learn anything interesting about that? So what I was doing is I was going through, I wrote out a large number of these images, which we looked through over the ML team with Moritz, and then I went back again and looked over them with Moritz, looking at the original reports and stuff. And basically from that we noticed that, again, ask me for details if you want.
Yeah.
There's like an issue with like how we do the labeling on the machine learning side, which it doesn't make sense medically. And in principle, it's common sense, and we could have thought of it the whole time, but it's only when you really sit down with the other person, you look through the reports, and you force yourself to think about it, that you notice these things. And that seems to have given us both an improvement in performance and also like a greater level of reliability. Like we seem to be getting more reproducible results now. So that was also pretty neat.
Okay. So does that mean that, because I always thought that the annotations are basically done, and then you just get that data and train and test the model. But so you're saying labeling is also done by you, and there was a discrepancy between the medical domain specifics and what you labeled, or? Yeah,
so just for a bit of context, like you're right that the original task is sort of set up by the business team eventually, right? But the specifics of what it actually means, I'm not tied down at all. So let me get, like, when you think of cancer or no cancer, right? That's what you're thinking about.
Yeah.
So what actually happens is you have two radiologists, as you know, and they both look at it, and then they have varying degrees of suspiciousness, and then there's a consensus conference, and then those people can have varying degrees of suspiciousness, and then maybe they'll have an ultrasound, and then maybe they'll have a biopsy, and then maybe that can be cancer.
Yeah.
Okay? So what you there is have like a gradual spectrum of suspiciousness. What is it we're trying to, which of those things are we trying to detect? Where's our threshold?
Yeah.
What should we show to the model? And that's where all the different kind of complication comes in. Like, for example, if the doctor needed a biopsy to tell the difference, maybe it's impossible for the model to tell the difference. And by showing it those two things as different labels, it's confusing. Or if the radiologist referred it, but it's not cancer, do we really want to say we think it's normal? Because then they see it it's something they would have referred, and it goes in their bucket. If you're not really sure if there's cancer or not, should you use that data? It helps because you have more, but maybe it's noisier. So it's just all the time how this sort of like radiologist crafted report maps onto something you actually learn from is there's many, many, many different ways of doing that. So yes, there's annotations, but the labels that the model sees are like very engineered.
Okay.
And so that's kind of what I'm getting at.
Okay.
So I'll give you the specific example because I think it might help.
Yeah.
So you know that when radiologists look at studies, they see a bunch of priors, right? They see like the women's exams from their past history, and they glean a huge amount of information from how it compares with the last one and the one before that, etc., etc.
Yeah.
Right. Our model only sees one image at a time, so it doesn't know anything about the prior. Yeah. Right?
Yeah.
So a bunch of the errors we found were things where the model says it's cancer. In fact, it isn't. But there's just an enormous mass in the middle there that looks like super suspicious. Okay? And if you look at the report, so the actual data, what happened is that it was there in the prior 3 reports, and 15 years before that someone biopsied it and found out it was benign. Okay? And that's why the radiologist said it was normal. But our model has no way of knowing that, right? The fact it's suspicious is right, because everyone's suspicious of it. right? So So what it led to is we led to a change where you say, okay, well, in order for us to say something's normal, it's not just sufficient that we think it's normal now. Like, nobody should have thought it was suspicious in the past.
Yeah.
Our model can't see the past.
But is that okay? Yeah, that's actually an interesting example. But ultimately, isn't it? I mean, that assumes that the biases that people have should be considered, right? Or not? Because if I mean, and from a naive perspective, you could just say we really just want to know what's normal or not, and there might be a similar case in the future, and the radiologist would always think it's suspicious. But since the algorithm was fed from this other example that it was normal, it just says it's normal. You know, why is it then important to have that kind of human element in the algorithm?
Well, I mean, just put it this way: like, if we had that other study in our data set, right?
Mm-hmm. Yeah.
We would be showing it the first time. We'd be saying it was suspicious, and we'd be showing it a different image of the same breast later, and saying it's normal, right?
Yeah.
This is not even self-consistent.
No, okay, that makes sense.
Right, and so I'm saying, like, a lot of the subtlety comes in, because on the one hand you say, yeah, we want to know cancer or no cancer, fair enough, but actually, if that was that woman's first scan, you would want to refer it, like everybody would.
Yeah.
Like it is. You could almost even have it as a suspicious label. Like, it's nothing's changed since when the first person saw it. They were like, "Holy shit, this person needs a biopsy ASAP." Mm-hmm. And it turns out they're just a weird edge case. So, yeah, what do you show to the model? Then do you worry that you're now not showing these types of things? I mean, the right solution is that you show all of the priors to the model, and it can use that information.
Yeah.
It's just that's quite difficult, and we're not there yet.
Okay.
So that's where there's this sort of like two-way process between the two.
Yeah.
And of course, it makes like common sense, right? Like, if there's a big mass in there, and you only know it's fine because somebody else was suspicious of it last time. It makes common sense, but nobody ever thought of it, including me, until we went down and actually looked through it. Yeah. So it's just a neat example.
Yeah, makes sense. So basically that interaction is you get a task, and then you go into the details and you notice that you need more specification as to what decisions to make, so you have to go back to, for example, Moritz and look at that again. So is that a way to...
The more honest description of what we were doing was phishing, right? I mean, the more honest description is like, systems are complicated, and you probably made mistakes. There's probably things which aren't logically the best thing they could be, and you're just out looking for them. We're looking through these errors and hoping you notice something, and then we did. That's a more honest description of what we were doing.
Okay.
I mean, you do think maybe, the errors it makes are all small masses, or the errors are all towards the side of the image. What does that mean? Let's change it. Those things happen too.
Yeah.
But there's also just like sanity checking factor, where you just like do stuff, check if it makes sense, and choose things which have like a high probability of showing something interesting.
Okay. So basically, do you do that on a regular basis?
Yeah, probably not often enough. We have done it regularly, but not often enough.
Okay. And so you just sit there and actually... I mean, is there a way to automate that, or is that just manual labor?
Yeah, it's sort of semi-automated. I mean, you write down, like... You feed the model tons and tons of data. I think what I did was I fed the model, like, every single image we have. Mm-hmm. And then you look, and then you rank them by how wrong the model was, and then you probably looked at the top 500 or something.
Okay.
Looked at top 500, and then if more, and then I filtered them for ones that look interesting, and so did Moritz, and then we looked through them together. And then the ones that were still interesting after that, we went through and looked at like the original patient history. That's kind of how we got to it.
Okay, that's interesting. Okay, great. So, I think that makes a lot of sense. So just to the only thing, I mean, we could go on forever, obviously, which is great. but just to summarize in terms of the timeline, what you're all of the challenges that we've been looking at, those are just, for example, the fact that noise makes it difficult to know the actual reason for the performance and so on, and the this phishing task and so on. These are ongoing things that one can say you're doing. That's just part of what you're doing, or just characteristics. And in terms of the timeline, so we had first the fast RCNN, then the patch-based model, which you started to build in spring 2019, right?
Something like that, yeah.
And then you had the new model, right? Does that have a name?
Yeah, it was the image-based model.
Okay. And the image-based model was... Did you start working on that? You deployed it in November because that, right?
Yeah, we started thinking about it a long time before.
Mm-hmm.
When did we actually implemented and tried it just before Christian and I went off to Canada, which was towards the end of November, I think. Something like that.
Okay.
That's when it was formally done, tried, and shown to be better.
Okay. And that's also now part of the product. Right.
That is the model in the product.
Okay.
One thing I would say I forgot. A big important part I think was really getting your evaluation tidy. So in two fronts, first getting a data set which we really cared about the performance on, but we were sure it was representative of what we want to do. Producing those data sets was done. I didn't do that. That was Benjamin and Stefan and Tyson stuff. I wasn't very involved, so you'd have to ask them, but I think that was very important. And also, in the beginning, we had just thousands of metrics, just loads of metrics, which was a bit confusing, a bit difficult to interpret. And at some point we all got together and decided what are the things what's the minimum set of things we actually need to know, which are really important, and let's implement them, make sure they're absolutely right, and then get rid of everything else.
So metrics, what does that mean exactly when you're talking about metrics?
So just the numbers which indicate how good the model is,
Okay.
You have some big model which does lots of different things, makes lots of different predictions, does well on some things, worse on some things, etc., etc. And maybe you might be looking at different stages in the model. The fast RCNN has got these different heads sticking on the end of it and all sorts of stuff. And you can extract numbers about how performant it is all over the place. Working out which of those numbers are important and then kind of getting rid of everything else and focusing on it. That in combination with data sets which were good at evaluating it. Evaluating a number of data sets would made a big difference, I think.
Okay, that makes a lot of sense. So that's basically, you were getting your evaluation tidy, meant first choosing a data set and second choosing the metrics, performance metrics. And was that a specific point in time where you realized that, or?
I don't really remember. For me, all of this is also overlaid on... This is my first job in machine learning, so it's also overlain on me learning how things work and what's important. But I think we did that towards the beginning of 2019, I can't remember. And certainly, my opinion would now be to do that as early as possible. Because you have this noisy evaluation problem we told you before, right? It's just getting that as under control as you can.
Okay. Makes a lot of sense. Great. I know we've already been more than 45 minutes, but I think that's already a lot of information and helps me a lot. Very interesting. So, I think as of now I don't really have any more questions, but maybe in terms of next to the interviews, the documents that I'm collecting. Should I approach Stefan first to see whether he already has an overview of the performance?
I think that's probably the easiest thing to do, yeah. Because I imagine they may have put it together for investor stuff already.
Okay. Yeah.
And if not, just send a message to the ML chat. Maybe even send it to the ML chat channel first off. Someone will know the easiest way to get it.
Okay, great. And then regarding, maybe that's also a question for Stefan, but regarding maybe an overview of the models. Did you ever have a presentation or something where you showed, hey, we used this model first and these were the results, then we used this model and these were the results? Do you have any documentation on that?
I gave a presentation when we first implemented the image model. I probably gave some. We had these model tuning meetings. I probably showed the patch result models when I can't remember when it. Because it's sort of the patch model. It sort of first came in a bit worse than the faster RCNN, and then slowly, through gradual model improvements, like you said, it did sort of slowly come up until it came past the faster RCNN. So I have stuff, but probably nothing as tidy as what you're after.
Okay.
We don't write up technical documents or anything like that for day-to-day model work. Like only for this other.
Okay, I mean, if you have that presentation and it's easy for you to give it to me, I mean, it won't be published or anything, and probably we're going to do an NDA anyway. If you have it and it doesn't cost you any time to send it to me, and you would be willing to, that would be great.
I can send it to you right now, but the only problem is we use one slide deck for the whole quarter, so.
That's great. I just need to. Basically, it would be good to show that I've also that I have some documentation that I.
I'm just making it all up. Sure. So I mean, basically, they're just called the model. It's called the model tune, like Edison model tuning slides, and you'll see there's like one for 6 months of last year. But we did update them all that. Because on the actual model work, it's typically only like 2 or 3 people doing it at any time. Sometimes just me, and then a lot of the information just gets conveyed in like chats in the kitchen and stuff. But then we just see. I just got a text saying that my housemates don't have coronavirus, which is pretty sweet.
Oh, that's great. Good to hear.
Okay, here we go. Model. Alright, well actually I'll compile it for you later. Let me just put it on my to-do list.
But don't take too much time. It can really be like really rough and ready.
No, it's literally just like sending you 2 links.
Okay, great. That would be great.
Good to do it.
Thank you so much. Yeah, alright. So, thanks a lot. It was good to talk, and I hope you'll be able to meet the people again. I wish you a good lockdown.
Thanks, man. You too.
Thanks.
And, don't directly quote me on the could be a different company.
No, I definitely won't. Don't worry.
Okay.
All right.
Anyway, see you later.
See ya. Take care.
Bye.
Bye.